Hello and Namaste. In continuation with the double integrals, we have started with the change of order of integration, and now we'll be including one more thing in it, that is the evaluation. How to change the order of integration that we have already seen in the previous sessions, and now we'll be including that evaluation part also in this type of question. So evaluate integration from 0 to 1, integration from x to square root of 2 minus x square of x upon square root of x square plus y square dy dx by changing the order of integration. Now if you'll observe here, this integral, we have got the two variables y and x, and if you'll observe here, the innermost integral is dependent on the x. That means y is absent over here. So inner integral is for y and the outer integral is for x. Now going ahead with the different curves, so we'll be moving ahead with the lower end of this particular inner integral, that is y is equals to x, which is a line passing through the origin. After that, we'll be moving ahead with this curve. This curve is nothing but y is equals to square root of 2 minus x square, that is nothing but x square plus y square is equals to square root of 2 the whole square. We can arrange that, and if you'll observe here, this is same as x minus 0 the whole square plus y minus 0 the whole square is equals to square root of 2 the square. That means it is a circle with center at 0 comma 0 and the radius is square root of 2. Third is this particular curve, which is x is equals to 0. X is equals to 0 is nothing but a y-axis. And then moving ahead with the fourth curve, that is the last, the value, upper limit of the outer integral, that is x equals to 1 is the line passing through the y-axis and passing through x is equals to 1, which would be the parallel to the y-axis. That means if you'll observe and if you'll just try to plot all these four curves in the graph, we'll be having the curve something like this, or this type of curve we have, which is the origin circle with the center at 0 comma 0 and the square root of 2 is the radius. So if you observe here, this is the point at square root of 2. Similarly, we have got the other two, y is equals to x, and everything we have plotted over here. Now x is equals to 1 is not been plotted here, but this particular curve would be moving something like this, because 1 comma 1 is one of the intersection. Anyways, we can plot this line in the next slide. The region is bounded by y-axis and the line y is equals to x, and the circle x square plus y square is equals to 2. Now, this particular, if you'll observe here, the point of intersection of the curves, we have to understand, we have to find out x square plus y square is equals to 2 and y is equals to x. That means, if you'll observe here, if you put x square plus y square as nothing but the x square is equals to 2, that is 2x square is equals to 2, that is x square is equals to 1. That means we have got this intersection as x is equals to plus 1 and is x equals to minus of 1. That means, and y is equals to x, that means the intersection or intercepts are 1 comma 1 and 1 minus 1 comma minus 1. These are the two intercepts of the circle and the line. Now this is the line x is equals to 1. X is equals to 1 is this line. Similarly, that's the reason if you observe here, this is a minus 1 comma minus 1 point. This is the point P, or 1 comma 1. So if you observe here, this particular, in the previous section, case also, we can just understand that, or otherwise here we can understand the region bounded by this particular curves would be nothing but the region which I have drawn it here, or the shaded here with the blue color, because the region which is bounded by y is equals to x line, the circle, and x is equals to 1 line. Similarly, this x is equals to 0 axis, which is a y axis. This is the region we have to understand here. Now that means, or otherwise the other way around is that inner integral is given to us with respect to y. So that means we have to take, or we have to take the strip parallel to y axis, and a dash b dash is the strip parallel to y axis. We have to take the lower end is on the line, upper end is on the circle, and the movement of this particular strip parallel to y axis is from 0 to 1, and that's the reason this is the region which we needed for this particular example. Now we have to do it, the change of order of integration, and we have to evaluate. Now change the order of integration, that is to integrate first with respect to x, because in the given equation or given particular question, we have been given the inner integrals for y. That means we are integrating with respect to y first. Now in the change of order of integration, we have to integrate with respect to x. Now dividing the region into three subregions, actually it's a two subregions, into two subregions OPR and PQR. So if you'll observe here, the two different colors I have shown it here, because of the point P over here 1 comma 1, this region is getting divided into two parts, because if you'll observe here, the change of order of integration, we have to check, or we have to take the strip parallel to x axis, and this lower and the upper end of the strip has to be there on the same curve. Now if you'll observe here, till the point P, the lower end is on the y-axis, upper end is on the y equals to x line. But as soon as it is crossing, this particular strip is crossing the point P, the lower end is on the y-axis, but the upper end is shifting from y is equals to x to a circle. And that's the reason this particular region is getting divided into, this particular one region is been divided into two different regions. Now considering the subregion OPR, so let me just erase it from this, so much of mess I've created. Okay, so the region is OPR. That means the region which is drawn it here, this is okay, this is drawn it in the yellow color. So if you'll observe here, OPR, the strip parallel to this is the strip AB, starts from y-axis and terminates on the line y is equals to x. So this is the region we are talking about. So limit of this particular, as I've told you, is moving from x is equals to 0, that is the y-axis, to x is equals to y line. And the limit of y, that means this particular strip is moving from this origin 0, 0 till the point P, and therefore the limit of y is from 0 to 1. And this can be shown in the particular integral as integration from y equals to 0 to 1, integration from x is equals to 0 to x is equals to y, x upon square root of x square plus y square dx dy. This is the first integral in OPR. Similarly, if you check the subregion PQR, so PQR, which is in the orange color, if you'll observe here, and this strip is the upper end and the lower end. So our lower end is on the y-axis and the upper end is on the circle. So the limit is moving from x is equals to 0 to x is equals to square root of 2 minus y square, because the equation of this circle is x square plus y square is equals to 2. That is nothing but, if in terms of x, it is coming out to be square root of 2 minus y square. And the limit for y, that means this limit is moving from the point P till the point Q. The limit is moving from 1 to 2. We have to check the y coordinate of this particular intersection points. So it is 1 to square root of 2. We can write down this particular I2 in this way. Integration from 0 to square root of 2. Integration from 0 to square root of 2 minus x square of x upon square root of x square plus y square dx dy. And therefore the change of order of integration becomes here this two integrals. So one integral, which was the strip parallel to y-axis given to us, has been converted into the horizontal strips, but this horizontal strips is giving us two different regions, and that's the reason we have to solve it here, one and two different integrals for the evaluation. Now moving ahead, that means this particular integral is equals to OPR and PQR. What is this? This is nothing but this limits what we have just now shown, seen here the last two slides. Similarly, now we have got, we can check that we have to integrate this particular inner integral is for x is equals to, That means if you'll observe here, the numerator is having the x. So if you'll take this other way around is, if you will take the substitution here, let x square plus y square is equals to some t, then it becomes 2x dx is equals to dt. That means x dx is equals to dt by 2, and hence the corresponding limit will change, because it's x square plus y square is equals to t, so corresponding limits will change. This is one way to go and solve this particular integral using the substitution. Other ways, now if you'll observe here, the differentiation of this particular x square plus y square is already present here, except this 1 by 2. So if you'll observe here, this is dt by 2, the same thing what we have done it here using the substitution. So this particular integral you can write down as integration 0 to 1 half x square plus y square to the power 1 by 2 divided by 1 by 2, because we are doing the integration of this, and limit is from x is equals to 0 to x is equals to y. Same thing we are doing it for this with the limit x is equals to 0 to x is equals to square root of 2 minus y square. Moving ahead, so we can just put the value of x is equals to y, the value of x is equals to square root of 2 minus y square, and the lower limit here will be getting the upper limit as integration from 0 to 1 square root of 2y minus y dy, plus integration 1 to square root of 2 minus y dy. My suggestion for you, just pause the video here, try to get the answer till the end, and then you just play the video so that you will be having a practice of your evaluation part. And this is what we are going to get it. Square root of 2 minus 1 is the out, which is a constant. Y square by 2 is the integration 0 to 1. Same thing is over here also. If you observe here, that means we'll be getting it this type of integration over here, which will gives us this particular, just by putting the upper and the lower limit, we'll be getting the answer as 1 minus 1 upon square root of 2. The same thing we can go ahead and find out. So this is what is the final answer for the evaluation part. It is same as that what we have done, the change of order of integration. In addition to that, we have to integrate the given integrals after changing the order of integration. And this is the self-observation slide wherein 1-2 questions are there along with the answers. Please do solve the questions. If you have any query, let me know in the comment section. I'm always there for help you out. Thank you. Happy learning.